In 1999, the last great physics experiment of the 20th century will be launched into space. It will be one of the most accurate spacecraft ever launched, with the world's most precise gyroscopes. Built as part of a 30-year project at Stanford University, in partnership with NASA, it's called Gravity Probe B. Spinning at 10,000 revolutions per minute in zero gravity, in a pinpoint orbit, the gyros will determine if Einstein's theory of general relativity is correct. But already the science of this highly complex experiment is developing a spin-off that could help save billions of dollars, thousands of hours of time, and untold lives. The first prototype cost only a few $100s in parts and is no bigger than a credit card. It's called the Stanford Integrity Beacon and works with unerring accuracy down to centimeters. It tells the autopilot where the plane is and lands it in the same place every time. And it was developed by a group of Stanford graduate students working on the gravity probe.
The integrity requirement of precision landing is one failure out of a billion landing attempts. And that is the order of magnitude that is required. That's the specification for really doing this right.
Here's how it works. Using special antennas, the plane flies through a radio wave bubble generated by the integrity beacon, which comes from two small ground stations. Then, with the worldwide satellite global positioning system as a reference, the plane can track the runway in the same place every time, regardless of the weather. It's August 1994 at Palo Alto Airport, where Cohen and 3 Stanford graduate engineering students are putting on a demonstration for NASA Administrator Dan Golden.
I thought it was really, really interesting. You could sit there and you could watch exactly where you are. You see when you come in the bubble, and then as the pilot is bringing it in, you could track exactly where the pilot is. And each pass, we made 3 passes, he came right down the center of the runway.
And the runway out here has variations of up to
Well,
a
I
meter.
saw that.
The demonstration was a success, but there was much more work to be done. The beacon had worked perfectly on small planes. Now it was time for bigger things.
And what are we doing here? We have no idea.
And that meant a bigger plane. For years, the Federal Aviation Administration and the airlines have been looking for a way to replace the nation's 50-year-old air traffic control system. GPS looked good, but hadn't been proven. United Airlines test director Jerry Aubrey thought the Stanford Integrity Beacon could provide that proof. When the FAA asked United to be a part of the test, he jumped at the chance.
It's a real big deal. We're basically looking at the combination of satellite navigation and satellite communications to completely change the way the air traffic control system runs. And we look to that as providing us with a more efficient operation at lower cost, and that's going to flow through our passengers.
The power ground and the frame ground is like a tenth of an ohm between them.
In early October, the grad students, with the help of United technicians, outfitted a Boeing 737 with antennas and computers. Objective, 4 days of testing.
The system is designed so that the GPS system looks to the airplane just like it's an ILS system. The signals the airplane is getting when we're doing the test approaches, the airplane's going to think it's flying an ILS.
An ILS, Instrument Landing System, proven reliable over the years. Can the Stanford Integrity Beacon match it?
Looks like everything's in shipshape here. We've got our...
It's day 1, and Cohen and fellow researcher Stu Cobb are making final preparations.
Did you pull the breaker?
United Flight 9465 is ready for departure from San Francisco. The plane is now experimental and will touch down over 100 times at the NASA Crow's Landing facility in Northern California to see if the Stanford project will work in a commercial airliner.
Here we go. We got our left pseudolite. Now we got our right pseudolite. So we're now in the bubble.
100 feet.
And we're now at about 100 feet. What's happening now is the radar altimeter is starting to take over. We're going to start to flare at 50 feet, which is right now.
50, 40, 30, 20, 10.
Another successful auto, and that is our number 6 back to control because we're flying out. We can still do centimeter level positioning, but now it's time to do another go-around. Stanford United core satellite mode.
The landings are perfect. The ground crew of Stanford researchers is elated.
Successful batch.
Hey,
Successful
all right.
batch.
In 4 days, the plane makes 110 flawless landings, satellite guided and on autopilot. Only one approach is called off, when the Air Force makes a minor adjustment in the GPS system. At a news conference, United Captain Bill Levy talked to reporters.
Well, it worked very good. You know, we started out, they're talking about doing 100 auto lands, and we thought, good grief, that's a lot of time to be spent out there. But once we got started, everything worked very well. We did 30 in one day, and 31 the next day, and 32 the next day, and then the final day, we went back and got 17 more. We started out for 100, and we got 110. Everything was working very smooth.
I'd feel a little bit nervous if I were in an airplane that was being guided down to the ground by a system designed by a student.
Well, these are very sharp students. I've really been impressed with these people from Stanford.
By golly, after the first successful landing, we knew things were going to work out fine.
We were perfect on the second day of flight test. I don't know if you could find another flight test program anywhere, anytime that was perfect on the second day.
Equally happy was the Federal Aviation Administration, which sponsored the 737 flight tests.
We're excited about it for a variety of reasons. One, because technically it's a very compelling demonstration of what we knew the technology was capable of. Secondly, we're very excited because you know, in the present climate with reinventing government and doing business smarter and better and more efficiently, we put together a very nice team of industry, academia, and government to bring this off. And the possibilities are endless in doing business that way, and we want to continue to do business that way.
The tests got a lot of attention in the press.
Federal Aviation Administration today praised a new kind of airplane landing system devised by a group of Stanford researchers. It means that soon we might be using satellites to land airliners. High-tech reporter Richard Hart takes us aboard a unique jet at San Francisco International Airport.
Flaps 30, final setting.
Satellites are revolutionizing the way ships and planes navigate.
Commercial jet pilots could soon be relying on a satellite positioning system developed by the military. As Craig Heaps reports, student researchers have figured out how the technology can help jets land in bad weather.
A graduate research project may revolutionize the aviation industry. Students at Stanford University have found a simple, inexpensive way to tap into the U.S. military's Global Positioning System, or GPS.
The airplane flies overhead. It picks up the signals from these transmitters on the bottom GPS antenna right there. It picks up the signals from the satellites on an identical antenna that's on the top of the airplane. The computer in the airplane puts all that information together and does a lot of math.
So, you see technology working for us. You're going to be seeing this apparently in commercial aviation fairly soon, because this exciting system really works very inexpensively, a good deal for everybody.
The long-term payoff of the Stanford project, says United's Aubrey, will be substantial.
The success of this test is going to go a long way towards having the International Civil Aviation Organization adopt GPS as a standard for precision approach systems in the future.
Which means that the Stanford Integrity Beacon can be used not only at commercial airports and for private aviation in the United States, but it can also be set up quickly anywhere in the world, allowing planes to fly into temporary emergency strips in case of disaster. And there's another benefit, according to NASA Administrator Dan Golden.
And these young people, they were being challenged to do things that have never been done before. So literally, I've said, you know, while they reach for the stars, they bring back benefits to society. And that's the whole object of the space program, to explore the unknown, open up the envelope, break down the barriers of ignorance, have fun, and contribute.
So 30 years of research on Gravity Probe B may have an immediate and present-day benefit that will save lives, time, and money. It's possible that this spin-off, the Stanford Integrity Beacon, could be operational around the world by the time Gravity Probe B is launched at the end of the century.
We set out to do one thing, and that was to validate Einstein's law of relativity. And as a product, we got a safer landing system that could allow America to use planes in a much better way. And so it's like Christopher Columbus. He came for gold and spices, and he went back with corn and potatoes.
It's fantastic, absolutely fantastic.